Applied Linguistics Group uploaded this video for BS English students. Dr. KHALID MALIK, the founder, has a PhD in Applied Linguistics TESOL. Having more than 25 research papers, he taught at many foreign universities and is now in a postdoctoral study program abroad. Join Applied Linguistics Group at youtube.com/@1966 Pakistani or use a QR code to join our Facebook group at
Computer in Linguistics. Computing has had a dramatic impact on the discipline of linguistics and is shaping the way we conceptualize both linguistics and language. Using computers in linguistics provides a non-technical introduction to recent developments in linguistic computing, and offers specific guidance to the linguist or language professional who wishes to take advantage of them. Divided into 8 chapters, each of the expert contributors focus on a different aspect of the interaction of computing and linguistics, looking either at computational resources, the internet, software for fieldwork and teaching linguistics, Unix utilities, or at computational developments, the availability of electronic texts, new methodologies in natural language processing, the development of the cellular computing environment for linguistic analysis. The computer science and linguistics combined major provides students with extensive background in the formal structures of natural, human, languages, as well as methods and applications of linguistic and psycholinguistic analyses of human language data. This is combined with an emphasis in computer science on artificial intelligence and natural language processing techniques. The major provides excellent preparation for work or more advanced degrees focusing on computational linguistics, natural language processing, speech perception, spoken language interfaces, artificial intelligence, and a wide array of related fields. The major in linguistics and computer science allows students to explore human, natural, language from a variety of perspectives, through courses focusing on meaning and linguistic structure at a variety of levels, sounds, words, sentences, with a range of electives in other areas. Students also learn about the organization, design, and construction of hardware and software systems for computing and discover how such systems can be programmed to process and analyze large amounts of natural language data. This prepares students for a variety of career opportunities in computational linguistics and natural language processing, including improving or developing new software in areas such as grammar checkers, machine translation, and information retrieval. It also provides an excellent background for students who wish to pursue graduate studies in these areas. By having computers in linguistics, Applied Linguistics Group suggested that student will achieve an understanding of the fundamental questions that drive modern linguistic research, along with foundational knowledge in the core areas of linguistic theory. The ability to identify and describe with precision the empirical patterns found in sets of language data, and to construct well-reasoned linguistic analyses by formulating, testing, and refining hypotheses about these patterns. The ability to understand and evaluate the organization, design, and construction of hardware and software systems for computing. The ability to analyze problems that require computation to answer, and to design and implement appropriate problem solutions that are efficient and effective. The ability to use computational tools, particularly those involving statistical and machine learning techniques, for language-related applications. Perspectives in computational linguistics. Computational linguists study natural languages, such as English and Japanese, rather than computer languages, such as Fortran, Snowball, C++, or Java. The field of computational linguistics has 2 aims. The technological, to enable computers to be used as aids in analyzing and processing natural language. The psychological, to understand, by analogy with computers, more about how people process natural language. From the technological perspective, there are, broadly speaking, 3 uses for natural language in computer applications. Natural language interfaces to software. For example, demonstration systems have been built that let a user with a microphone ask for information about commercial airline flights, a kind of Automated travel agent. Document retrieval and information extraction from written text. For example, a computer system could scan newspaper articles or some other class of texts, looking for information about events of a particular type and enter into a database who did what to whom, and when and where. Machine translation. Computer systems today can produce rough translations of texts from one language, say, Japanese, to another language, such as English. Computational linguists adopting the psychological perspective hypothesize that at some abstract level, the brain is a kind of biological computer, and that an adequate answer to how people understand and generate language must be in terms formal and precise enough to be modeled by a computer. Assuming a single, the relationship is a bit overly simplistic. Here are a few. 1. Working linguists often have practical problems in data management and analysis that are solved or assisted by computer software. Some of these problems are fairly specific to linguists, and thus present new areas of research in computer science to figure out how best to solve them. In this respect, linguistics is not unique. You could say the same thing about the relationship between, say, agriculture and computer science, or parcel delivery and computer science, or business management and computer science. 2. Linguistics and computer science both deal with the recognition and generation of languages. The languages each deal with on a regular basis fall into quite different qualitative categories, but they have underlying structural, mathematical similarities to justify the common term, language. Research into computability thus influences linguistics and vice versa. 3. Humans like computers to automate tasks for them, but don't like having to figure out how to talk to computers. It'd be nicer if computers could comprehend and act on commands given in native human languages. Figuring out how to accomplish this requires a combination of CS research in machines learning algorithms and NLP, and linguistics research into semantics, sociolinguistics, and cognition. Problems in computational linguistics. From both perspectives, a computational linguist will try to develop a set of rules and procedures, e.g. to recognize the syntactic structure of sentences or to resolve the references of pronouns. One of the most significant problems in processing natural language is the problem of ambiguity. In 1. I saw the man in the park with the telescope. It is unclear whether the man, or the park has the telescope. If you are told by a fire inspector, 2. There's a pile of inflammable trash next to your car. You are going to have to get rid of it. Whether you interpret the word it as referring to the pile of trash or to the car will result in dramatic differences in the action you take. Ambiguities like these are pervasive in spoken utterances and written texts. Most ambiguities escape our notice because we are very good at resolving them using our knowledge of the world and of the context. But computer systems do not have much knowledge of the world and do not do a good job of making use of the context. Approaches to ambiguity. Efforts to solve the problem of ambiguity have focused on two potential solutions, knowledge-based and statistical. In the knowledge-based approach, the system developers must encode a great deal of knowledge about the world and develop procedures to use it in determining the sense of texts. For the second example above, they would have to encode facts about the relative value of trash and cars, about the close connection between the concepts of trash and getting rid of, about the concern of fire inspectors for things that are inflammable, and so on. The advantage of this approach is that it is more like the way people process language and thus more likely to be successful in the long run. The disadvantages are that the effort required to encode the necessary world knowledge is enormous, and that known procedures for using the knowledge are very inefficient. In the statistical approach, a large corpus of annotated data is required. The system developers then write procedures that compute the most likely resolutions of the ambiguities, given the words or word classes and other easily determined conditions. For example, one might collect word preposition noun triples and learn that the triple "who saw" with telescope is more frequent in the corpus than the triples "e man" with telescope and "e park" with telescope. The advantages of this approach are that, once an annotated corpus is available, it can be done automatically, and it is reasonably efficient. The disadvantages are that the required annotated corpora are often very expensive to create, and that the methods will yield the wrong analyses where the correct interpretation requires awareness of subtle contextual factors.
Applied Linguistics Group uploaded this video for BS English students. Dr. KHALID MALIK, the founder, has a PhD in Applied Linguistics TESOL. Having more than 25 research papers, he taught at many foreign universities and is now in a postdoctoral study program abroad. Join Applied Linguistics Group at youtube.com/@1966Pakistani or use a QR code to join our Facebook group at